All right, we're going into probability 7-5, compound events. The first two vocabulary words, I'm not quite sure how important they are. A simple event is just a single outcome. Compound event is an event made up of two or more simple events. Pretty much just wording here, but we're just going to see probability questions for the day. Now, there are two important words. There's mutually exclusive events and inclusive events. So mutually exclusive events are events that cannot occur at the same time, the same trial. So, for example, if I had a deck of cards, what's the probability of drawing a king or a queen? Well, you flip one card, you can't have a card that is both king and a queen at the same time. So these are two mutually exclusive events. You know, you got to figure out the probability of getting a king, probability of getting a queen, but you will never flip a card that is both king and queen. That's mutually exclusive. Inclusive events are events that have one or more outcomes in common. So I can take that same deck of card question here, and you can see by the Venn diagram here, there's event A occurring, event B occurring, and then there's some little bit inclusive overlap here. So if I say, what's the probability of picking a card and it being a king or it's a heart? Well, this would be inclusive because there is one card that is both king and a heart, and of course that's the king of hearts. So what we would do with that is figure out the probability of a king occurring, probability of a heart occurring, and then minusing out the times where they are, how many cards that are both kings of hearts, which is only one. Now it's pretty, if you look at these tables here, it's kind of confusing. A lot of this is just, with some of the problems are going to be way simpler than what this would imply here if you look at this. But just keep in mind, mutually exclusive, like the Venn diagram shows, are two events that there's no reoccurring of the two events. Inclusive is, you know what, there are some times where you can have outcomes that are kind of overlapping, and you don't want to include that probability twice. You need to minus it out. Okay, so here are a few examples of today's work. Number one. What is the probability that you spin this wheel and landing on an odd number? Well, there's 12 numbers here, and 1, 3, 5, 7, 9, and 11. 6 of them are odd. So what's the probability of getting an odd? It's simply 6 out of 12, which of course is 50% or 1/2, 50%. What is the probability of the wheel landing and being a multiple of 4? Well, you got to know what a multiple of 4 is. There's 4. Well, let's just count that. There's 8, and then there's 12. So there's 3. There's 3 outcomes there. So multiples of 4. 3 out of 12, which is, you can reduce that to 1/4 or 25%, however you want to play around with that. Okay, number 3. Find the probability that the wheel is landing on a prime number. So let's put a little tick marks here. What are our prime numbers? These are numbers that can only be divided by itself. And by the way, 1 is not a prime number, so this is not a prime. 2 is a prime number. 3 is a prime number. 4 is not a prime number because you can divide it by 2. 5 is the only number you can divide 5 into. 6 you can divide into 3 into 2. 7 is a prime number. 8 is not a prime. 9 is not a prime. 10 is not a 11 is prime. And again, for our purposes and by definition, 1 is not considered a prime. So there's 1, 2, 3, 4, 5 prime numbers. So you would go 5 out of 12. All right, let's go into mutually exclusive and inclusive events occurring. A player can win a prize if the player's spins lands on an odd number or a multiple of 4. Are these mutually exclusive events where the results of an odd number or multiple of 4 never overlap? Or are there some numbers that are odd numbers and multiples of 4? Mutually exclusive or inclusive? This one is mutually exclusive because all the odd numbers, 1, 3, 5, 7, 9, and 11, are not multiples of 4. So what is the probability of getting an odd number? Well, we actually figured it out, 6 out of 12 here. And then what is the probability of being a multiple of 4? We actually figured out there's 3 of them. Multiples of 4. 4, 8, and 12. Those 3 of them. So 6 odd numbers, 3 multiples of 4, that's 9/12, which is 3/4. This is a mutually exclusive event here. Okay. I put this under 1 fraction, but you could go, well, the odd numbers are 6/12. You're going to add that with the multiples of 4, which is 3/12, and thus you get 9/12. Finally, the last one here. A player can win a prize if the player's spins land on an odd number or a prime number. Are these mutually exclusive events or inclusive? Mutually exclusive means there's no overlapping. Inclusive means there might be some odd numbers that are also prime numbers. So, what is the probability that this will occur? Okay, so first of all, this is inclusive because there are some odd numbers that are both odd and prime. So first of all, the odd numbers, of course, there's 1, 3, 5, 7, 9, and 11. There's 6 of those. How many prime numbers are there? Well, we actually figured it out earlier. There's 2 is a prime with the check marks here. 3 is a prime, 5 is a prime. There's 5 of these guys. We're going to add those together that are prime. But there are some numbers that are both odd and prime. So 2 isn't even. 3, this is both odd and prime. We don't want to include that twice. 5, that's both odd and prime. This is both odd and prime. And this is odd and prime. So we're actually, within these 5 prime numbers, we've already represented them as being an odd number as well. 3, 5, 7, and 11. So it occurs 1, 2, 3, 4 where they overlap. So what we're going to do is minus out those 4. 6 plus 5 is 11, minus 4 is 7/12. So 7/12 is the probability that you get an odd number or a prime number. And in fact, the 7 of the 12 is, that's odd, that's prime, that's odd and prime, that's odd and prime, that's odd and prime. This is odd, and this is odd and prime. 1, 2, 3, 4, 5, 6, 7. 7 out of 12. But again, you don't want to count twice because this is both odd and prime. So you don't want to stop here and just say it's 11 out of 12. That's inclusive events. You need to minus out when they happen twice.